working now. All right. So last time I kind of blitzed through this composition idea where you can just keep stacking stuff in the same line. Because you figure when a function returns something, remember that function gets evaluated to the value that that function returns. So if I call do stuff, and who cares what do stuff is actually doing, but I call do stuff. Like look at the first one with do stuff 2, I know there's 2 of them. But look at the first one. If I call do stuff 2, it returns a value. It's going to return like an integer, or maybe it was a float, I don't remember. But it returns a number. And same with the other do stuff 2, it'll be the same number, hopefully. So if those 2 function calls get evaluated to a number, then the outside do stuff has the parameters that are basically just the 2 numbers. I'll show you what I mean. So if I have a line like this, if I hit run, it's not going to work because the do stuff's not defined. But if we pretend that it is, there we go. If I pretend that it is, you figure this function is going to go, let's say it gets to line 4. Python will say, well, I got a function do stuff. And it takes the parameter, oh, look, there's another function call. All right, I better go evaluate that function. So it goes into the do stuff function, does all the number crunching, and it returns some number. I don't know, let's say it's like 50. I have no idea what it is, but let's just pretend it's 50. And then over here it goes, oh, look, there's another function. I can evaluate that. All right, so 50, great. And then it goes, oh, yeah, of course, I can do stuff at 50-50, and then that'll turn into whatever this gets evaluated to. Maybe it's like 500. I don't know, 5,000. So we can do this. We can like just keep stacking these things, nesting them in each other. But I don't, as a default, I'd be cautious of doing this. Just because you can doesn't mean you should. That code is a little bit harder to chew on. If you submit an assignment and I look at a line of code like that, I'm going to go like, ugh, what the heck? What is this doing? Where if you took the time to spread it out over like 3 lines and you were assigning it variables, well, if it's good variable names and whatnot, and a good function name, do stuff isn't a really good function name. But if it's set up that way, it's going to be a lot clearer to anyone reading the code. Readable code is good. And if I told you and I showed you, like if I gave you this ladder activity here, no, the first one, do stuff. If I said, calculate this, I think I have an extra parenthesis. Oh no, I don't, it's good. If I gave you this, and the function do stuff, which is defined there, you could evaluate all of this with pencil paper. You don't need Python to do it. You can just follow the code and just do the number crunching yourself. So instead of like these computers doing the number crunching, you are the thing following the algorithm doing the number crunching. You figure the code really is just some encoding of instructions. The system doing the decoding and actual execution of the instructions could be this, or it might be you. I could follow the code and execute the exact same instructions, and it'll get me the same result as the computer would. So, it's kind of neat. But anyways, if I asked you to do this and said, what's the answer here? You could just do this calculation. There's no magic. Just follow what the code says. All right, call the function do stuff. With the parameters, well, okay, look, those parameters aren't values yet, so I'm going to have to do number crunching of do stuff 2. And then it looks like I'm going to have to do stuff 2 plus do stuff 4. Like, there's a lot going on, but you can all do this. The one trick, the magic silver bullet strategy for understanding what the code's doing is read the code. Follow it slowly, make no assumptions, and you're good to go. I saw a lot, and I love this, because early in the semester, we always get to 2 key things. You know, I always emphasize, like, oh, we'll Google it, you know. And then, again, that's not because I'm trying to be nasty, but because That's when a programmer isn't debugging, they're Googling stuff. So for example, in lab, people were asking, well, how do I round stuff in Python? And I say, well, okay, go to Google and type in Python round. And sure enough, you'll find a solution. You'll find, like, Python's round function. It's great. But raise your hand if you used it and it didn't operate like you expected immediately. More people should have noticed it, but a couple of people's hands are up. So the Python round function actually will round up or down to the nearest even integer. Not that rule you always follow of like, well, if it's 5, you round up idea. Does anyone know why we do that? So raise your hand if you learned, whenever you're rounding a number, if you ever get something that's exactly between, like 0.5, you just round up. Raise your hand if you learned that. Of course you did, everybody did. Well, in practice, that can actually create a lot of issues if you're rounding up all the time. Because if I give you the number 51, that'll come out to 25.5. And if I give you 25.5 and you round both up, you get 26. And then, well, now you have 26 and 26. If you put them back together, you got 52. Magically, we got another value in there. With the rounding even one is if you had a whole, like if you just kept rounding and rounding and rounding and rounding, the idea of rounding to the nearest, like if you get to a 0.5 and you round to the nearest even integer, the value there is hopefully for every time you round up, you'll also round down to cancel out any of those like little rounding errors that might arise. But that's beside the point. The point is, you get a function, you use it, and if it doesn't work like you expect, read the documentation. The documentation is usually a couple of sentences. But if you read the documentation, which, you know, I can stand here, wave my finger at you about like, always read your documentation. Yeah, I definitely am bad at that, where I'll just find the function, use it, scratch my head for 5 minutes, and then read the documentation that takes 2 seconds, and then go, oh, okay, that's how that function works. Because as soon as you read it, you saw like, oh, rounds to the nearest even integer. And, oh, okay, so that's how it works. Raise your hand if you used sign in function, in Python. Did it work the way you expected the first time?
Actually, yes.
Yeah? How about anybody else? No. What were you expecting?
I was expecting you just put sign in and it would do it.
Well, there's that. So here was hoping that would, who here was hoping that would happen? Yeah, I would totally hope that happens. Unfortunately, it doesn't. More on that in a moment. But another thing that people will get to is you expect to be able to type in like 90 degrees and it'll work. But unfortunately, like most things in the world, if you're doing any trig, it expects radians, not degrees. So if you're pumping in degrees, expecting it to work with degrees, you're in trouble because it's actually expecting radians and you get some funny errors there. So just be careful, read the documentation. What does the code say? Take your time. Don't make assumptions. Be careful. Okay, variable scope. I think this is where we ended last time. But if you create a variable inside a function, for example, in do more, you see the variable c. If I try to access c outside of that function, Python will say, well, that doesn't exist. I'll show you. Put this here. And then let's say, do more of 5 and 6. Okay, great, so I ran it. So do more ran. And I know it does. I know it did because I just hit run and there's that little checkbox. But if I want to say, okay, well, what's print C? It doesn't exist. It only existed inside that function. That function gets called, the variable C gets created and used, and as soon as the function's done, it gets thrown away. If you call the function again, okay, great. Another variable called C gets created, but once that is done executing, it gets thrown away again. It only exists inside there. So scope will get you You'll make those mistakes every once in a while. Raise your hand if you've had this issue before. Yeah, I saw there were a couple of people in the lab that saw that. That's typical. Okay, sometimes, and this isn't going to be coming up very often, but I'll show you nonetheless. Sometimes you can actually define your functions with like a default value, where if you don't specify the value for a given parameter, when you call the function, it'll just assume the default value. So here is an example. If I call, so here's a function, oh, I'll have to import math. Okay, great. I define time to fall, and have a look-see. So this variable, or this function, will take two parameters. D, which I guess is distance probably could have used a better variable name. And there's another variable A. I'm guessing it's for acceleration. But the default value there is set to 9.807, which is like the acceleration due to gravity on Earth on average, right? So if I ever call this function, if I don't specify the acceleration parameter, it'll work, but it will always run with the acceleration set to 9.807. So, t equals time to fall. Let's say it's 11 units. And yeah, I'll just run that. Whoop. There. It'll take almost 1.5 seconds if it's 11 meters high. Cool. See, I didn't actually have to specify the A. Where before, if a function was expecting two parameters, I only gave it one, Python yells at you saying, you gave me one, I needed two. Here, it's fine with that. Because if I don't give it a value, it just assumes, oh, okay, well, it's 9.807. But then of course we could then say, well, let's say I want to run it again, except, I don't know, what's acceleration due to gravity on Mars? It's probably, I think it's less than Earth, right? So maybe it's like 7.6. 7.6, perfect. So if I hit run, there. It'll take 1.7 seconds. So now I can actually specify a different value. It's a neat little fact, FYI. Now, import. Raise your hand if you've ever used import before. A lot of you have. I saw you do it in lab. So, whenever you turn on Python, whenever you load it up, Python gives you a bunch of stuff for free by default. For example, print. It's just there. As soon as I turn on Python, I can call the print function. There's a couple of other ones that you get by default. I think abs for like absolute value you get by default. There's a bunch of other things there. A lot you get by default. But the number of functions that Python could give you by default is hilariously large. But the problem is, including all that stuff up front has a big computational cost to it. There's a lot of stuff that's got to be loaded up if you want to include all that stuff. So Python gives you, a bunch of stuff as soon as you load up, but it excludes everything else by default. Until you go, okay, look, I'm going to be doing a bunch of math stuff, so I will import math, and then when I do that, Python goes, oh, okay, so here, we'll also load up all the math things as well. So you go out of your way to specify what you want to also include. And like most of you saw in lab, math is a really good example of that. Math, we all want to do a sign calculation every once in a while, but you don't get it for free by default. But all you have to do is just say import math, and boom, you got it along with a whole bunch of other math stuff. There are two common ways that you can do, let me me see. Okay. There are two like common ways you can do like an import. If you want to import very specific functions, you can specify it a certain way, like or and that star. So, for example, say I have a collection of functions called myfuncs, right? I could write from myfuncs import star. Star means everything. Like just import everything that's stored in the myfuncs collection of functions. And then great. It works. It's great. You can just call the functions however you want. Let me reset this runtime and show you an example of how that would work. So here, if I try to say like sign, print sign of 0, and I hit run, it'll say sign's not defined. So a way to import it, to solve this problem, is I could say from math import. I could specify only sign, but for fun, I'll say star. And now when I hit run, it works just fine. Sign of 0 is 0. So this works just fine, yeah. The star means everything. Import everything. I could specify like import sign and it would only import sign. But with this I can import like cos as well and just everything else in the math collection there. Yeah. Yeah, because if you're writing code and you want it to be very like lightweight when you're running it, and you like there's still a lot of functions in the math library. And if you only need one, maybe you only import the one. I usually almost always though, unless I'm doing like machine learning with some beefy stuff, I'm usually just, well, I'll show you what I do. First, I will never do imports like this. I would strongly suggest you don't import stuff this way. You can, there's nothing wrong with it, but by doing it this way, you're taking a bit of a risk. So, I'm going to restart the runtime again. Yes. And just to verify, print sign of 0. Just to make sure, yeah, okay. So I restarted the runtime and this doesn't work, as we expect. The other way to include all these things is to write import math. So before it was from where, import the things you want to import. If you do it this way, it still won't work if I just write this code. And the reason for this is it's expecting you to specify where that function is. And by default, it's looking like at all the functions you wrote in your code. And it goes, but it's not there. So what I would actually write here is math.sign. And now it works. And now you might say, well, why would I do it this way when the other way is less typing? Raise your hand if you're kind of like, yeah, why would I do it that way? The other way seems easier. Yeah, it totally seems that way. But the problem here is when you specify, like if I look at this code and see math.sign, I know exactly where that function's from. There's no ambiguity of, did you write that function or did you get that function from somewhere? When you do from something import star, it's kind of like you've copied all the code in another file somewhere and pasted it into your code so it thinks like you wrote it, kind of. Where when you do it this way, you specify from where, so from math, call the sign function. And then I can do print from math, call the cosine, look at all these things, look at this. The ceiling of 55.01, I don't know. Right? I can call all the functions, but anyone looking at this code will know, oh, okay, that came from the math collection of functions there. Imagine for a second I'm going to restart my runtime one last time to show you an example of where the other strategy will cause big problems. So from math, import star. And I'm also going to define a sine function. Clearly, the sine function that I just wrote isn't correct, but it's there. So now, when I hit run, see, I'm doing from math import star, so that means I don't have to say math dot. When you look at this code, which version is it going to run?
Yours.
Mine? Why? How do you know?
Because you wrote it, it makes more sense to run yours.
It makes more sense, but do you really know that, or is that your guess? See, the problem here is suddenly we have some ambiguity. Suddenly, I look at this code and go, uh-oh. They're calling, but I don't know. Do you have a question?
No.
Then don't worry about it. So let's see what happens. So it runs mine, but I mean, I could stand up here and just as easily tell you, well, no, it could run the math one, and you'd believe me, because there's nothing here to really indicate. Where if I had it the other way, where I said math.sign, and I've got this sign, there is no ambiguity. I know which one I'm calling. In fact, there is another library I can include called NumPy. It's got a lot of similar things to the math. So it's fine. But the problem is NumPy has a sign and math has a sign function. So where before you were able to guess, like, I guess it makes sense that the priority would go to the function that you wrote and not the one that you imported. And that's reasonable. That's a fair assumption, even though it's still ambiguous. There's some intuition there. The problem is, if I go look at the documentation for math, I will find a function called sine. If I go look up at the documentation for NumPy, it will include sine. And they'll act a little bit different in slightly different scenarios, depending on how you use it. So now when I say print sine of 0, and I hit run, I don't, which one is it running? The one from math or the one from NumPy? Why are you saying that?
Because it's the last one you did.
You think so, yeah?
That's my guess.
It's the problem is it's your guess.
I'm pretty confident I'm correct, but I can't be 100% sure.
You know how you could be 100% sure?
Got it.
If you do this.
Fair enough.
Which version of sine am I using? The one from NumPy or math? There is no ambiguity. So now you're in great shape, yeah.
I'm just wondering what's the difference between NumPy and math that you know about.
That's a fairly big question. NumPy just has more and its backend's a little bit different than math's. It's a very more, just use math for now.
Okay, so just ignore NumPy?
No, but don't use it now, because you won't need it right now, but we'll use it a little bit later.
Okay.
It's got more like heavy-duty operations in it, and there's like sub-packages in it, like if you're doing like linear algebra, where math maybe doesn't have those in there or something. But there are some slight differences in how they also operate. NumPy also gives you additional data structures that are kind of fast. NumPy, a lot of its backend is implemented in C, where math is just Python code. So if you're doing some heavy-duty scientific calculations where there's a lot of number crunching, NumPy might give you a bit of a speed up, but there's also an overhead with that maybe you don't really care about. I could keep going, I won't. Interesting question nonetheless, because you go like, well, they're similar. The reality is you can go download a bajillion libraries that all do very similar things. You can import a whole bunch of them. But you're only going to use what you need right now, so math's doing a good trick for us.
Okay.
Cool. And then, as most people saw, comments. We like to write comments in our code when we need to explain something. If there's some code that might not be particularly obvious about what it's doing, we can write a comment to describe it. Sometimes you might write a little comment to describe like a couple of lines. Sometimes you'll write it to describe a whole function. Sometimes you might write it for a single line of code. If I have a line of code that's like A equals 55, no, let's say, no. And mass equals 66. And I say, probably don't need to comment that line. Because you can go and be like, oh, they're calculating the density, and they're storing the variable, like the value in the variable density, right? Probably don't need to comment that line. But if you start to have more and more complex chunks of code, where it might not be immediately obvious right at the get-go about what's happening, you can write a little comment in that code. The comments are just words for the human to read. Python ignores those lines. It means nothing to those lines. It means nothing to Python. So if I have like, maybe I would say, leave this, leave this, it calculates the important thing. Probably you're going to want a more descriptive comment, but as a contrived example, there's some very complicated code. Maybe I write a couple of lines describe, like just a comment saying, like, okay, this chunk here does this. So yeah, as soon as Python sees that like hash sign, it ignores it. Comments are great if you make, it can make your code easier to read. And it's particularly valuable, like in reality, if you continue to program later, maybe you get a job as a programmer, you're gonna be working with other people. Sure, maybe you will remember what you were doing. Chances are you won't. It's a common joke in computer science where it's like, I don't need to comment my code, I'll remember what this does. And then it's like, come Monday, you look at it and it's just like a bunch of hieroglyphics because you don't know what you were doing. Like, comment your code. But it's that much more important if I need to share my code with someone else. They're gonna want to know what on earth it is that is going on. And there's so the like hash sign, the number sign, pound sign, whatever you want to call it, is for a one line, and there's nothing stopping me from doing more lines like this. But I can also do like this to get like multi-line comments if I just want to write like a book here. All of this code just gets ignored. A human can read it, But Python just goes, oh, okay, whatever. This block here between the 3 quotes is just ignored. One thing I'm going to have you all do is write function headers. Even for simple functions, you're going to write what we call a function header. It's a description of what the function does. So setup cities is a function that exists in assignment 2. And, I mean, it prints 1 plus 2. Obviously, that's not what it's going to do. But there's a complicated function that you have to use. You're not going to write it. I give that function to you, I think. Maybe I don't. Maybe I make you write it. Either way, let's pretend I give it to you. Like the load data for assignment 1. I have this function header that says set up a collection of cities. For our simulator, each city is a 3-element list, and our world will be a list of whatever. And then you see param names. Param, and see how it's in between like colons? That's a special thing that means like, okay, the parameter names is a list with the names of the cities. And then I also have this return between those colons that describes what the function will return. We write these function headers like this, and it's a common, like, if you're a Python programmer, you're gonna do this. You're gonna write your function headers like this. It's the standard, everyone's following it. And what's really cool about these function headers is, like, if you write like a big library or something and you want to generate documentation for your code that you wrote, that you want to share, you know how like there's that, like, if I go to Google and type in math, Python, perfect. Zoom in a little. So here's all these things in math, right? Like I can just keep going and going and going and going and going. But like, this documentation here, see how it like explains, oh, and I guess they weren't really following the convention perfectly. But for each function, it kind of like explains what's going on. These are automatically created based on your function header. So it's kind of like a neat little thing. That it just like makes your documentation nice for you. Oops, wrong way. So yeah, there we go. Comments, blah, blah, blah. Cool. Any questions about that? All right. So we learned about a bunch of types. We learned about integers, we learned about floats, we learned about strings. You might remember we briefly a little bit talked about the none type, which is special, right? Because like integers can have like, in theory, like an infinite number of values it could take, but they're all integers. Where like strings, similarly, you know, we could have any combination of strings, but they're all strings. But with none type, it has one type and only ever one value. If you have something of none type, its value is just none. There's another type we're going to talk about today called Boolean that can only ever have 2 types. It's one type with 2 different values, true or false, 0 or 1. So far, we're pretty good at telling Python what we know. But if I came along and said, using only the Python features or statements we've seen so far, can you write a program that will divide a number in half only if that number is a multiple of 2, or if that number is even? Same thing. Could you do that with only the stuff we've seen so far? No. We don't have a way. Sometimes in the past they'll make you try this, and yeah, good luck. We don't have a way to make a decision. We don't have a way to check, like, well, is it divisible by 2? You know? So, first we're going to talk a little bit about simple logic. We can talk about Booleans, and a Boolean is either true or false, okay? And I can ask you a question that can get evaluated to a Boolean. Am I wearing a hat?
No.
I don't want to hear no.
False.
Am I wearing a hat?
False.
Am I wearing shoes?
True.
Am I wearing a shirt?
True.
Am I wearing a wristwatch?
False.
Exactly. Not mind-blowing, but this is advanced stuff. So now, we're familiar with operators on numbers. The operator plus. If I give you two integers, the plus sign operates on two integers, okay? If I say 1 plus 1, that means add, and it gives you back 2. So plus is an operator that takes two numbers and gives you back a number. Plus also works on strings though, right? If I give you two strings and say plus, it concatenates them and gives you back a string. So the operator plus can take like two numbers, gives you back a number, maybe it takes two strings and it gives you back a string. We're going to talk about some other operators, and, or, and not. These are operators, just like addition, but where addition takes two numbers and returns a number, and or will take two Booleans and give you back a Boolean. Now, I'm going to try to convince you right now that I don't need to teach you any of this. You are all very aware of how this works. Am I wearing a hat and shoes? Why is that false? I don't have a hat. I have shoes, but I don't have a hat. How about this? Is James wearing a hat or shoes? Why?
Because it's one or the other. You get at least one.
Yeah, and that's how or works. Not only in like formal logic, but also like in like everyday parlance, you know? How about, is James not wearing a hat? True. So an interesting thing about not is, unlike and or that needs like two Booleans, not only takes one and just flips it. So when I ask a question like, am I wearing a hat and shoes? Here's what your brain's doing, whether you like it or not. Your brain is going to go, okay, is he wearing a hat? False. Is he wearing shoes? True. When you have something that's false and true, that's false. False and true is always false. It might seem weird because we're used to cutting out like the middleman there, where we don't go, okay, evaluate to true or false, and then operate on true and false. But that's what's happening. If I give you a statement that can be evaluated to true, and another statement that can get evaluated to false, and you try to AND them together, you always get back false. Am I wearing shoes and a shirt? Why? I have both on. Like, it's obvious, right? So I would encourage you to do this activity. We won't do it now for lack of time, but you can generate like a truth table where, here, you know what? I'll draw it real quick. Here's often how we do it. If you can't see, I apologize. But maybe I'll have like condition A, condition B, and then AND. And then I'll also evaluate for OR. Okay, and what I want to do, I'm going to write T and F for true and false. So what I'll do is, I want to describe all possible combinations of true and false between two values. So I can have true, 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 false, false, true, false, false. Can you see back there? I'm guessing not. Yeah, kind of, yeah, all right. So, if I have two things that are true and I add them together, what do I get back? Am I wearing a shirt? True. And shoes? True. What's the result? How about with or? Am I wearing shoes or shirt? Who thinks true? Raise your hand. Who thinks false? Really, one person. Usually more people get tripped up on this one. So what you're thinking about is something called exclusive or. And English is actually interesting because there's a special word for it, I can't remember what it is, but English has an ambiguity in the word or because it might mean exclusive or not, but whatever. I'll let you know right now, all that matters for or is that one is true. If they're both true, great. If we're talking about something called exclusive or, it's only true if only one is true. If they're both false, it's false. If they're both true, it's false. But let's not worry about that right now. So if I have something that is, am I wearing, and I need everyone working here, am I wearing shoes or a shirt? Of course. Now, am I wearing shoes and a hat? So this gets evaluated to false. What about, am I wearing shoes or a hat? Am I wearing a wristwatch and a shirt? Well, I don't have a wristwatch on. How about wristwatch or shirt? How about, am I wearing a sombrero or a wristwatch? It's obvious. How about a sombrero or a wristwatch? False. So it's kind of neat, right? Like, true and only ever gets evaluated to true if both conditions are true. Or is always true unless both conditions are false. In fact, here's a question for you. I don't have an eraser. Oh, here's one. If I not working too well. Actually, yeah, I can do it for the other one as well. I don't even need to know what B is for these last two to know what the result of and is, right? If I have something that's false, and I don't even care. If one is false, and gives me back false. So I actually don't even need to care about the second condition, the second Boolean value. Is it false and? I don't care, it's false. Similarly, with true, using the or operator. If I have something that's true or, doesn't matter what the or is. True or whatever always gets evaluated to true, which is kind of neat, right? Now, if I have something that's false or, well, I mean, I can't conclude anything yet. And again, similarly with and, if I have something that's true and, well, I can't answer until I have both operands. But sometimes we can actually kind of short circuit the question and get to the answer quicker without even needing to know the other, which is kind of cool, right? So we just talked about and, or, and not. Not just, I could draw not over here. What's not true?
False.
What's not false? Of course. So that's an example, and, or, those are examples of operators that take two Booleans and give you back a Boolean. Let me show you. I can say, true, and false. It's false. True and true? It's true. True or true? True. False or true? How about this one? Not. Ooh, what's this get evaluated to? Well, way to spoil the fun. True. Why? Well, not false is true, and true, well, that's just true. So those are operators that take two Booleans and gives you back a Boolean. But we also have operators that can take two numbers and give you back a Boolean. Let me show you what I mean. First, actually, let me convince you that when you see true or false, bool. It is its own type. But let's say 5 equals 6. Notice the use of two equals here. Let me ask you, does 5 equal 6? No. Of course not. Does 5 equal 5? Yeah. Does 5 equal 4? No. I mean, this is always going to be false unless they're both, unless the right hand's 5. But I could change this. What about this? Does that make sense? Yeah, true. What about, here's a funny one, what about this?
False.
Not true? Raise your hand if you think it's true. Nobody. All right, well that's good because it's false. 5 is in fact not greater than 5. It's equal to it. So I could say this. Greater than or equal to 5. Yeah, cool. All right, I'll see you later.